everyone, and welcome. I am Aurora with the Central Coast Astronomical Society. I'm the current president, and tonight I want to welcome you to a special event that we're doing. We are going to be doing a tour of the night sky with our special astronomer, guest astronomer Kent Wallace. He and I will be taking you on a tour of the night sky, so when you go out and look up tonight, providing the weather holds out and looks good, or even if it doesn't, you can do this anytime afterwards. You'll be able to really start to feel your way through the night sky and also really get some good distinctions, maybe on if you're already a seasoned astronomer and you already know your way around. Kent is going to give you some really extra cool things to think about to take your stargazing to the next level. So if you're ready, say, oh yeah. Okay, I actually would, it is my privilege and honor to be able to do this to you tonight, to do this presentation with you tonight with Kent Wallace. Now, when I first started out in astronomy 15 years ago, Kent was one of the people I would always park my telescope next to because just his immense wealth of knowledge in this area was just surpassed any computer program that was available or any sky atlas I could try and figure out how to read right side up. So Kent is an amazing resource, and he is an incredible human being that has over the years been my personal mentor in this area, and I was just so happy when he said, yes, of course, I'd love to help tonight. So Kent, are you there?
Yep, I'm there. Thank you.
All right, Kent. So how long have you been stargazing, Kent?
Since high school.
Since high school?
So that's over 40 years. Probably closer to 50 years.
Yes. Okay, so what many of you may not know is Kent doesn't have any star atlases in front of him tonight. In fact, he's not even looking at a computer screen, which is why I can't show you his face. He's on a rotary phone, and he is going to be doing his tour of the night sky with you completely from memory. So if you have any questions, you'd like to see something special, you have a question about what we're talking about, please type it in the comment box. You'll find it below. If I'm full screen, hit escape so you can find the comment box pop up. And I'll be stopping periodically to read those so we can continue throughout this. Now, Kent, when you first started, you were mentioning a book that was really instrumental to you. Is that right?
Yeah, for learning the constellations. It's The Stars by H.A. Rey. H.A. Rey was the guy that did the Curious George stories. I don't know if anyone's old enough to remember those.
Yes, definitely.
I think Curious George once in a while plays on PBS.
Awesome. So just getting to know the constellation. So what would you say, Kent, before we get started, the most important thing for maybe somebody who's just started out, what would you say?
Basically, if you can get the book, it's still in print, started in print in 52, and a red flashlight and a pair of binoculars would give you a real good start. And I started actually started off by seeing the belt of Orion and then building off from there.
All right, so speaking of Orion, why don't we just get started? So I have the night sky here. This is a program called Stellarium, Stellarium. You can download it for free and install it. You put in your address and it knows exactly where you are and what time you're stargazing, and it will show you the night sky. There is a complete guide to how to use this on our website, but right now I'm going to use it to navigate the night sky with you. As Kent is talking, I'm going to be pointing things out. Now, for those of you who are more seasoned astronomers, I would recommend a pencil and a piece of paper as we do this. Kent's going to be sharing a lot of information, and if he says something that you're interested in, please jot it down so you can look it up more later. All right, Kent, so I have Orion here. What do you want to tell us? So if somebody's looking for Orion, what should they be looking for?
Okay, right now, Orion's kind of in the south to southwest once it gets decently dark. Mm-hmm. And the thing to me that kind of pops out is the belt of Orion. There are three stars in a straight line, equally spaced, and about the same brightness. So it's kind of unusual and kind of sticks out. So that's a good starting point.
Awesome. Okay, so as you guys can see here, I've got the constellation. I can turn things on and off as we need them. So initially, when you look for Orion, you're going to look for the three belt stars. And then, do you see the sword here? Those are the sword stars he's talking about. So Kent, what is this fuzzy thing I see right in that sword area?
Yeah, that's the Great Orion Nebula, Messier 42. And that's visible in binoculars. It doesn't look like much in binoculars, but it's visible as a fuzzy spot.
Awesome. Okay, let me pause you right there. So, what you're seeing now on the screen is what the Hubble Space Telescope can take, or what a backyard telescope, actually, this is more like a backyard telescope, isn't it? And so you're not going to be able to see all these colors. So when you look through a pair of binoculars, you're going to see a fuzzy patch. And it's going to look a little greenish, and it's going to look like a smudge, kind of like this. But through a telescope, you can get it to be much larger. So the pictures here that we're going to be showing you when I zoom in, typically it's it's an image that's already been taken that's laid on top of this program. So it's not going to be what you're going to see through binoculars. I'll try to make the field of view similar to your binocular field of view, which would be about, depending on the size of the binoculars, about like that. Okay, Kent, so what's so cool about this nebula?
Well, there's several things. One thing that's cool, in the 8-inch telescope, you've got the trapezium right in the center. Be like four stars forming a rough, kind of squished rectangle. And those are very young stars. This is a star birth area. And I think, what is it? It's about 1,500 light years away, roughly. Um, Normally you can see the four stars easily in an 8-inch telescope. There's actually two more stars. The four stars they call A, B, C, and D. There's also E and F stars, but they're harder to see. You have to have, a really good seeing to bring those in. And with my 20-inch, you can actually see, I see green around the trapezium, and then out on the outer edges, I get kind of a burnt orange, like an arc. And so you can actually see colors when you start getting around the 20-inch range.
Now you use a special filter, don't you, to really see some of the nebula?
Actually, you don't need it on this one because it's so bright. Certain things you do need the filter, an O3 filter on, or a UHC filter on, would be like the Veil Nebula, supernova remnant. That's quite faint. That'll make it show up. Planetary nebula show up good. Actually, you will get a boost off of it, but usually it looks so pretty by itself, outright visually, that you don't need a filter for the Orion Nebula.
Got it. Now, what were you telling me about Orion when we were practicing yesterday? You were mentioning something kind of near M42 here.
I know, let's say, well, in the belt, we have the Flame Nebula next to one of the belt stars there. I think it's the Eastern Belt Star. And that shows up in an 8-inch scope. And then not far off of that's the Horsehead, but that takes a big scope to see. And I'm trying to think also, Rigel in the foot is a double star, and that'll show up nicely in an 8-inch scope.
That was the one. Okay.
Okay, the double star Rigel.
Yeah, here he is. Okay, so let me put on the star names so you can see them. There we go. Okay, so here's Orion, for those of you who are still getting oriented. Okay, so there's Orion. And so this is the double star he's talking about here. And what can you tell us about Rigel?
Rigel's like a blue supergiant. I think it's roughly about 500 light years away, but don't hold me to that.
Okay.
And diagonally across the constellation Orion is Betelgeuse, up in kind of like the shoulder of the giant. And recently we were talking about how that's been getting dimmer. It's a variable star, and it's gone through a pretty low point in its brightness, but it's starting to come back. And people were talking about, is it going to go supernova? It will one of these days. I mean, it's losing a lot of mass. It's a red supergiant, and in fact, I think they've picked up some mass loss around it using, I don't know if it's an infrared telescope or something like that. So It's in line to blow up one of these days.
Between now and million years from now, yes. Awesome. Now, one of the things I was noticing over here, there are 3 open clusters in different stages of development. You want to tell us about the other 2? So we have the Orion Nebula.
Right. In fact, I'm looking at your list right now, which
Yeah.
really helps.
Oh, good.
You've got Orion. You've got 3 million years old for it.
Mm-hmm.
For the actual actually the cluster, the stars, and in fact, the Hubble took pictures of disks around some of the stars in the Orion Nebula, which was really, it's actually solar systems forming.
Wow.
And so, M42 about 3 million years old. Next one you have is the Pleiades Messier 45, 100 million years old. So that's a much younger cluster and a pretty one. It's a binocular object. I think it's in Taurus. It's naked eye. It looks like a baby dipper or small little. In fact, when I was a kid, I thought it was a little dipper, but it isn't. It's just a nearby open cluster. And also the photographs show like a blue cloud around it. I think the cluster is actually going through a nebula or dust cloud. And it's really hard to visually see that nebulosity. You can do it, but you've got to have good conditions to pull it in.
Awesome. Got it.
And the last one's the Hades, which is even, that's a little bit older, 600 million years. And it's kind of like a wide, a roughly triangular cluster off of Aldebaran in Taurus. And it's more of a binocular object because it's really spread out.
Got them. So in this one part of the sky, you can see 3 open clusters in different. So this one's just a few million years old. This one's like 600 million years old. And Pleiades is about what? Maybe 100
million.
About 100 million? Yeah, so that's kind of a cool thing you can look for. Nice. So what about this red eye of Taurus? So most people can find Orion, but one of the things you were telling me is look for the really bright stars that you see in the night sky. So I've zoomed out here, Kent. We're facing kind of southwest, and I've got Orion, and then I've got yeah, go ahead.
We talked about the Great Hexagon, or some people call it the Winter Hexagon, that includes the bright stars in the winter sky. And that, if we start at, let's start at Rigel, the foot of Orion, and then we go up to Aldebaran in Taurus, which is the brightest star in Taurus, and it's like a magnitude 1, I believe. And then go up to Auriga, you've got Capella, which is a magnitude, I believe it's a magnitude 1 roughly. And the next jump is Castor and Pollux, which is the head of Gemini. And those are naked eye stars that are quite bright. Then you drop down to Procyon, which is the Canis Minor, the little dog, and there's not much there except for Procyon. Then we drop down to Sirius, which is the brightest star in the sky, which is in the big dog, Canis Major, and then finally back to Rigel in the foot of Orion. So that's what they call the Great Hexagon.
Awesome. Perfect. Yeah, and tonight you're going to see Castor and Pollux pretty much overhead. Is that right?
They should be up pretty high. Yeah, it's kind of a neck breaker. It's hard to see things that are straight overhead, especially with a large telescope.
Yeah.
It depends on the type of scope you have. Some are easier, some aren't.
Right.
But usually straight overhead is, even trying to get in the finder scope, you usually have to twist your neck at a weird angle to shoot straight up.
Yes.
But, if you're just looking with a pair of binoculars, it's not too bad. Or you can sit in a chair or something like that and look straight up.
Yes, yes. Oh, and you know what? I should probably say, Tom Fry wanted me to share a picture with everybody. Let me pause you right there. He has a binocular chair that he has used over the years, and he sent me a picture to share with you. Check this out. This is what Tom likes to stargaze with. So he made this. It's PVC pipe. He got plans from a fellow, and you can always contact him if you're interested in building one of these yourself. And if I remember right, Tom, it's on a turntable as well. I need to pipe Tom in here now so he can talk to us. But you grab either side of these and then you can tilt, and it's not a net breaker as much. So he's got a pair of, I think these are 10 by 50s in there. So that's also a possibility. Okay.
Well, yeah, when something like that is also really useful when you get bigger binoculars. Let's say 2100s.
I just happen to have some right here. It's funny you should mention it. Look at the size of these suckers. You keep talking, Kent. Go ahead. I'm gonna try to hold these up.
Literally, it's heavy, and kind of your arms wear out trying to hold them up. Where if you've got a nice chair like Tom's put together and has support for the binoculars, it really makes it a lot easier to deal with.
Yeah.
One thing I've done over the years is I've used my 750 so much, I've built up the strength in my arms to hold them steady, all through, through a lot of the night as I jump from object to object.
Yeah.
But it takes initially, the weight is a little bit hard to hold. You actually have to build up your muscles to hold it for a long time. So that's something, although the binoculars nowadays are a lot lighter. I use my grandfather's old 750 naval binoculars, and that's when they made them pretty beefy and pretty heavy. The ones you get at Big 5 today are a lot lighter.
They are. I have a set here of 10 by 50s I've had for about 10 years. These are Orion Ultra Views, and they're really great. They're not as heavy as Kent's, I think, World War II ones.
Yeah, that's what they are. It's a World War II binoculars.
But they work just as well.
BU ship binoculars that my grandfather had.
Yes. All right, so what else would you look at? So we've got the big stop sign, we've done Orion. What else would you look at with binoculars for tonight?
For binoculars, just outside of the Great Hexagon, over from Castor and Pollux, the head of Gemini, would be the Beehive, M44, which is in Cancer. It's actually a naked eye object if you have a dark sky, and it's a big but faint open cluster. And it's really a nice binocular object.
Perfect. And so this is what you'd see through a telescope. This has a field of view here about, less than a degree. And through binoculars, it would probably look more like this.
It looks a lot better in binoculars than it does because you have such a small field of view.
You do. You really do.
Another one, which is kind of cool, that you can see in binoculars is M35 in the foot of Gemini. And that one, you can just pick it out as a fuzzy area. It looks really nice in a telescope. And there's a NGC cluster right next to it that's 4 times further away. Remember how we were talking about that?
Yes, I have it here. I'm going to back out slowly. Here, we'll keep it centered here, and I'll back out slowly so you can see where this one is, both of these that he's talking about. You can kind of see near the foot of Gemini where that is. Okay, go ahead, Kent.
Yeah, that's a nice open cluster that's fairly easy to find once you get down the constellation of Gemini. Oh, one more thing about the Great Hexagon is Betelgeuse is right roughly in the center of that. So that's another kind of neat indicator.
Nice. Awesome. Okay, what else should we go look at? We can go anywhere you want. Where do you want to go?
I'm thinking below Sirius, which is, the brightest star in the sky, and also Sirius is a double star. But you have to have really good seeing, you have to have a good scope, and there's a few little tricks to bring it in. I've only seen it in fact, only once. And but it's because it's a white dwarf and Sirius is so bright that they call it the pup. And you know, it's not an easy target to go for. But anyhow, below Sirius is Messier 41, which is another nice open cluster. You can see it in binoculars, but it's not bad in a telescope. Let's say an 8-inch telescope, because that's what I'm used to.
Got it. And I've got that one right here. So this one's called the Little Beehive, but I haven't heard that before.
Yeah, that's, you know, people put names on stuff all the time. It's the main thing about nicknames are fun. It makes it easy to remember. And, you know, usually if a nickname will last for 50 years, it's going to stick. You know, if it doesn't last for 50 years, someone will call it something else later on.
Yeah, I'm sure that's true. I'm sure you've heard quite a few in your day.
But putting nicknames on stuff, oh yeah, Planetary Nebula are just loaded with nicknames. I've made lists of names for Planetary Nebula because there's so many different names that have popped up. And then for Astronomy Picture of the Day, when these guys find new objects, they like to throw a nickname on top of it.
Of course they do.
What's really bad is when the thing has had a nickname for over 100 years, they didn't know it, and they made up a new nickname. Like the Bug Nebula, which was Barnard's one, that's in Scorpius. It's a planetary nebula, and he called it the Bug in his discovery paper. And it's been called the Bug for about 100 years, but once they got Hubble photos of it, someone started calling it the Butterfly Nebula, and that's been popping up. But it's really, you know, President says it's the Bug Nebula, named by Barnard.
Huh.
So I could go on for nicknames forever. There's so many things that have nicknames out there, but that's, you know, that makes it fun.
Yeah, it does make it fun. That's awesome. Okay, great. So we've looked at Orion. People are familiar now about Sirius the dog, and we did the big stop sign you can see here on top of Gemini. We've got Venus here. Oh, you know, we didn't talk about the ecliptic. Do you want to tell people about that?
Okay, ecliptic is a line that's drawn on a lot of the charts. It's actually the path of the sun across the sky. And, you know, basically our planets you can see and the ones you can't usually are very close to the ecliptic, because that's essentially the plane of our solar system. So you see the ecliptic, it'll always be plotted on a star chart. And in fact, the other day was the first day of spring, and just the night before at around, I think around, what was it, 8:50, the sun crossed that line. Or, let's see, was it crossed that line? Something like that. You had the vernal equinox. I guess it's a mark on the ecliptic. When it crosses that mark as it moves along the ecliptic, that begins spring.
Mm-hmm.
But anyhow, that's pretty much, you know, the thing about the ecliptic.
Got it. Yeah, I've got some paths. If you guys see the red arcs here, those are individual. This is the orbit of different planets. You can see Venus is over here. I can take away the horizon, and now you can see the sun is over here. So it's below the horizon, obviously, because it's dark. And if we went even further down here, we could see where the moon and Mercury. And you see all the planets and the moon and the sun all follow this arc through the sky. So if you go outside and you kind of know the path that the sun made or the moon is making through the sky, and you look up and you see bright things that you haven't seen there before, or things that don't really twinkle, chances are that's a planet.
Yeah, in fact, the zodiac is developed off of the ecliptic.
Mm-hmm.
Those are the constellations that the ecliptic runs through. You know, when they talk about you're a Leo, in fact, if you start Leo, and then the next one's Virgo, and the next one's Libra, then you've got Scorpius, and you've got Sagittarius, and you've got Aquarius, then you've got Pisces, and you've got Aries. Taurus is one of them, and Gemini is one of them, so there's two of them in the Great Square, and then Cancer, and then you go to Leo, and then you're back at Virgo, and that's pretty much the runaround.
Okay, you did that way faster than I can point, but yes.
Yeah. I didn't expect you to follow it, but
I was gonna try, but it didn't work.
yeah, it's the classic astrological constellations are the ones that the ecliptic runs through. You know how they talk about Jupiter is in Leo or something like that, you know?
Yeah.
That's part of the horoscope stuff.
Right.
And, you know, that's another thing about the ecliptic.
Awesome. Okay, great. So where else should we go? We got a pair of binoculars. We're going outside tonight. What else should we look at?
Well, let's see. There's, we haven't talked much about Auriga, which is, you know, you've got Capella's the bright star there. And basically, the constellation Auriga looks kind of like a pentagram. And two of the lower stars in the pentagram, right between them roughly is a nice open cluster called Messier 37. And that'll look like a fuzzball in a pair of binoculars.
Okay, got the fuzzball. Perfect.
And it's actually, in a telescope, it's a really pretty open cluster.
So in a telescope, it'll look more like that. Perfect. So now you know where to go. You're looking for, where are we? Here we go. So you're looking for these stars and relative to other ones. So the idea is you learn the bright stars, Sirius, so forth, and Rigel, and then you start to see the patterns of the constellations. And then from there, you can go to find these other things. So if you know where Orion is, and well, here, let's turn off the constellations and the names. So if you know where Orion is here, and you've got Sirius over here, and we've got the Eye of the Bull here, so you know almost straight overhead, you're going to have this 1, 2, 3, 4, is it 4? Is it 5 or 6 stars in Auriga?
Oh, in Auriga? You know, I think it's like 5.
5, okay.
I could be wrong, but I think it's like 5.
It's like 5.
And then, you know, one other thing down below it in Taurus, there's one bright star down below that's kind of like the horn that comes off the bowl. I think it's Zeta is their name for the star, Zeta Taurus. The Crab Nebula is right near there. Remember we were looking at that?
Oh yeah, let's look at that one here. Let me. One of the things you can do on this program, I've been trying to show you different features. So if you want to if you don't know where something is, you just type M1, and then it'll center it for you, and then you can simply zoom in and give you information along this side. So here is now. What's so cool about M1? Would you actually see this amazing blast that I'm looking at, or no?
No, you know, it's a telescopic object. It'll look like maybe a fat S shape. You know, it's mainly a blob. The important thing is it's a supernova remnant that when it blew up, they saw it here in 1054 AD. The Chinese had records. There's a few other folks that had records of it. The Europeans didn't say anything because in 1054 you'd probably get burned at the stake for mentioning that. So they don't have any European records of it. But, you know, it was quite a bright supernova. And, you know, since 1054 AD, it's expanded into this nebula. And supernova remnants are fairly rare. There's not that many of them that are targets for a, let's say, an 8-inch telescope.
Nice. So if I have my 8-inch Schmidt, I could go out there and I could find this.
Oh, yeah. Yeah, you could find that. And I don't know if any of you have gone out and looked at Venus lately, but Venus is very bright. It's very high in the sky.
Yes,
and
yes
so
it is.
It'd be a nice target.
Let's see if we can find Venus. Here, I'm going to turn everything off. Can you guys find it? Here, let's see. Oh, if I turn off the labels of everything. Oh, for some reason, oh well, Venus would be the one that says Venus next to it. Perfect. Okay. It's right there.
And I would guess that it's probably like, you know, it goes through phases. When it's in the west, it starts out like full phase, like a full moon, and then it gradually goes to a half moon as it moves, you know, as the days go on. And when it's heading back down to the horizon, it'll be a thin crescent. And so right now the phase may be a half moon, I'm guessing.
How did you know? You're amazing.
I haven't gone out and looked with my telescope recently, but and then when it does set, it'll pop up in the morning as a very thin crescent, and then it'll get fatter in the morning and go through the same cycle. When it heads back down in the morning towards the horizon, it'll be almost a full moon, and then disappear and pop up in the west.
Awesome. Okay, let me pause you there. Let me see if any questions have come through that we can answer. So I haven't actually been looking at the questions yet. Oh my. Okay. Question. So I'm planning, this is from Aaron, I'm planning a trip to Black Mesa, a dark sky location. I'd be there at a, is that a good time to see the Milky Way the clearest? Would that be in May?
May. Yeah, if you stay up a bit, don't mind staying up a bit late. The Milky Way, let's say you stay up like 4 hours after it gets dark. I think the Milky Way will be starting to come up about that time. And it'll look like a cloud bank over in the east. And then, if you stay up a couple more hours, it'll rise up further. Also, Scorpius will be coming up with it. That's another precursor. I'm going off memory from out at Navajo Flats because it's got a really good eastern view out there. And, May, there's some neat stuff. You've still got a lot of the spring constellations. You're kind of between spring and summer. So Leo is probably still up. You've probably got the, what's that constellation? Coma Berenices, which is a nice binocular, great big open cluster that's spread out. And so you'll have to stay up a bit. It's not going to initially be up there, but if you stay up late, it'll come on up.
Okay, awesome. Perfect. How are nebulas formed? This is from Sophia.
There's actually, nebula means cloud, and usually they're dust clouds. Carbon materials, hydrogen. If the hydrogen's excited, it'll give you a red color in a lot of the photographs. Our eyes aren't very sensitive to, the hydrogen line in there. It's a red line. It really takes a bright source to be able to see the redness. But nebulas are clouds. There's different ways they form. There's a lot of dust clouds just drifting around in the Milky Way. It's raw material to form new solar systems. And so, like the Pleiades, they're going through a dust cloud. You get this nice reflected light, gives you what they call reflection nebula, which is blue. And that's why the cloud around the Pleiades, if you look at one of the nice photos of it, you'll see all this blueness around it. And that's a nebula there. You get different nebulas like planetary nebula are caused by stars, relatively normal stars dying. And they actually shed outer layers. The remnant of the star turns into a white dwarf and gives off hard ultraviolet. And the hard ultraviolet makes the planetary nebula glow. And if you Google planetary nebula, you'll find all sorts of wonderful shapes and colors from planetary nebula. So stars can make planetary nebula. Also, they can shed the raw material that'll become nebula. And there's like a bunch of different classes. It's like supernova remnants. The Crab Nebula, that's a nebula that was thrown up by a supernova. There's also Wolf-Rayet stars that produce nebulas, like I'm thinking of Thor's helmet. That's Wolf-Rayet star is a very massive young star that's just throwing off material. And so, you could get this really neat, with an O3 filter and a 20-inch scope. It really looks fantastic for Thor's helmet. There's another weird one. You have to go down to, the southern hemisphere. Eta Carinae. It's got 2 lobes on it. And I remember in the 8-inch, when I was down in Western Australia, I could see orange in one of the lobes. And that star kind of had a hiccup. It's probably going to go supernova one of these days, but it blew out 2 great big lobes over, I think, about 150 years. And so there's a lot of different sorts of nebulas. Where stars are being born, they usually call that emission nebula, a lot of hydrogen, like the Orion Nebula is a good example, where you've got a lot of red emission. If you see green, that's actually ionized oxygen, or what they call O3. It's actually doubly ionized oxygen. And they have filters for that that'll make it really enhance the view. But anyhow, that's some about nebula.
Awesome. Thank you, Kent.
Welcome.
Okay, so I was thinking, Kent, why don't we head over to show people how to find the North Star?
Oh, the North Star, okay.
And what's so special about that one? Like, how would you find it?
Well, one thing is it's always there. It doesn't move. So that's one indicator. It's the in-star, how you've got the almost everyone knows the Big Dipper. And so you've got a handle on the dipper. Same thing with the Little Dipper. You have a handle and then you have a bowl. The in-star in the handle of the Little Dipper is the North Star. And it's not that bright a star. I think it's around the 3rd magnitude, something like that. People expect that the North Star should be bright, but it isn't. The interesting thing is that it always is in the same spot. So if I'm out at Navajo Flats, it's going to be in the same spot it was 10 years ago. It does not move. All the other stars make circles around that. Stuff rises in the east and sets in the west. And, because the Earth is rotating. But the North Star, which is called Polaris, happens to be on the axis of rotation for the Earth if you extended it up in the sky. So it actually makes a very small little loop, but you usually have to use astrophotography to be able to see it. And it is a double star. You'll see a bright, in a telescope, you'll see a bright yellow star, and then right next to it there'll be a little bluish star. And that little bluish star is 3 times brighter than our sun.
Wow. Let's see if this program actually has that information.
Pardon?
Maybe not. Okay.
I'm just going off memory here. I
know. Yeah. For those of you that just joined us.
There's another way I just remembered, I think.
How's that?
Isn't there, let's see, I'm thinking that the 2 in-stars off of the Big Dipper, the bowl, point, I believe, to Polaris also. And so if you know the Big Dipper, you pick 2 in-stars, the in-stars on the bowl, and draw a line off. And I think it intersects Polaris also, if I remember right.
Yes, that's correct. It does, and that's the handle of the Little Dipper.
Yeah, and, it's actually, unless you're in a nice dark area and your eyes are good, it's good to have a pair of binoculars. You can follow the handle and then to the bowl. That book, H.A. Ray, the really nice thing about it is it has overlap. So it has, like, the constellation it's focusing on, but it also shows you the constellations around it. So when you get the one constellation that you get familiar with, you can look over and go, well, this is just over to the right from it. And it makes it real easy to learn the sky that way.
It is. It is. For example, I've got the Big Dipper here, and then if you look over here, let me turn this off. I've got the Big Dipper here that we just talked about with the North Star here. But then I've got this backwards question mark. Do you see that? Here, if I connect the dots, you can probably see it.
Oh, the backwards question mark thing is in Leo, I think.
That's Leo. That's right. Leo the lion.
And, that's part of the lion that sticks out. It's kind of like the head and the mane. And then there's a long back to a triangle at the end, which the end star is called Debnola, which means the tail of the lion. And then at the bottom of the question mark, you've got Rigel, which is, again, another first magnitude star.
Rigel or the other one that starts with an R?
I'm sorry, not Regulus.
You got it.
Regulus, yeah, not Rigel. Rigel's in Orion. Too many R's, you know.
No problem. You're doing with this on a rotary phone without any star charts. I think it's no problem.
But yeah, Regulus is like a big indicator, but it actually looks like a lion. If you look in the H.A. Ray book and follow it along, or you go to a star party and someone's got a green laser, they can point it out. But it does, roughly appear like a lion.
It does.
So that's a nice thing. And Leo is a spring constellation. It's in the area of galaxies. There's not any real binocular objects in Leo to go after, but there are galaxies. There's towards the that triangle at the back with Debnola. Just below it is a grouping of galaxies. Actually, 3 galaxies. They call the Leo trio. There's M65, M66, and I'm trying to remember there's an NGC galaxy. So there's some
3628.
That sounds right, yeah. And so that's more of an edge-on type galaxy. Nice pictures of it show kind of like a dark lane running through it.
Nice.
But yeah, those 3 are really close together there. The other 2 are, the Messier ones are spirals. Now, there is in the Psi, there's Gamma Leo, which is a really neat little double star. It's like a pair of little orangey stars. And it's right in the center of the Psi.
There we go.
Yeah, we talked about that the other night. That is really, that's, for an 8-inch telescope, that's a nice double. Another double I forgot to mention was Castor. You got Castor and Pollux, or the 2 bright stars in the head of Gemini. Castor is a nice double star for an 8-inch scope. If I remember, it's like 2 white stars that are fairly close to each other.
And that's going to be almost directly overhead when you look tonight.
Yeah, it's tough.
It is tough.
Stay up late. If you stay up late, it'll move over some and get down lower.
Yeah.
But I think we're supposed to get rain tonight. So
so that's why we're doing this.
Probably not the best night, but and then later, it's going to be up there for a while. You can wait till next month or the month after that. It's still going to be up, and then it might be in a lot more convenient place to try and take a look at.
Yeah. Tell me about M44, since we're near it.
M44 is the beehive in Cancer.
Did we look at that one already?
We were talking about that earlier.
Oh, we did. Okay.
That it's naked eye in a dark area like out at Navajo Flats.
That's right.
You can actually see it. And there's let's see if I remember right, it was used as a weather indicator. If you could see it, you were going to have clear weather. But if it wasn't visible, it meant that storms were coming. That old folklore stuff from ancient years.
Awesome. So, was there anything in Coma Berenices you wanted to talk about?
Yeah, there is. Well, Coma Berenices is a big open cluster. It's a binocular object, but in front of it, I believe to the west of it, there's a really neat edge-on galaxy, one of the best edge-on galaxies in the sky. It's called NGC 4565, or the Needle, and it looks awesome in my 20-inch. Kind of stretches from one end of the eyepiece to the other, but it's really a nice edge-on galaxy. And you can actually use a couple pairs of stars in the Coma Berenices cluster to point you right at that galaxy. And I don't know if you can blow it up enough to show them that or not.
Yes, yes, I can do that. Now, how would you find this? You know, Coma Berenices is not like Orion trying to find. It's like...
No, it's harder, but it's, you know, actually binocular is the best way to, you know, start off on that. Because it's such a, you know, it's good size, but it's, you know, not super bright.
No.
And,
so if you look here, we've got Leo over here and the Big Dipper over here, and you can kind of see where we are between the two of them.
And it's also naked eye. I mean, you can look up, if you're somewhere dark, you can look up and see it. It's not really bright, but it's, you know, this extended object up there. And, you know, it's kind of like there's a handful of things that are naked eye targets. And, you know, we were talking about the Beehive, M44. That's an old one. Real obvious one is double cluster in Perseus.
I was just thinking of that one. Let's introduce Cassiopeia, shall we? Here, we're gonna turn more north here. Okay, now we're northwest.
So that's, you know, Cassiopeia is something that's more of a fall constellation for it rising in, you know, out of the muck to the northeast. And it's kind of like a W, but, you know, Cassiopeia has some interesting stuff in it. There's a really neat open cluster, I think it's NGC 457. They call it the Owl cluster. I've heard it called the what was it?
I've got the Dragonfly and the Owl and the ET cluster.
Yeah, ET, that's it, ET cluster. But, you know, it looks like what it is, the way the stars in that cluster are spaced out, through my 32 millimeter eyepiece, it looks like a stick figure owl. You can see little feet, the wings are kind of going up, you've got two bright stars for the eyes.
For the eyes, and here's the wings.
In fact, you've probably seen it in my scope before at the star parties. It's a popular one that I like to show the folks because, especially children, they have a good imagination for stick figure objects. And this one looks like an owl.
It does look like an owl with little eyeballs here and the wings and the feet. Totally.
Yeah, it's really a neat open cluster. It's not like your typical open clusters, the way it's spread out.
Yeah.
But it does form a figure, and so that makes it kind of interesting. And there's actually a very interesting double star in Cassiopeia called Eta Cassiopeia. It's between two of the brighter stars, kind of in the middle of it. And it's got a companion that's a red dwarf star. And it's one of the brighter red dwarf stars in the sky for the double. And I don't know if you can find Eta Cassiopeia there.
Yeah, I'm trying to figure out how to put the star names back on so people can see. Here we go. Let's see. Okay, so I've got star names on. So for Cassiopeia, I've got... See, what have I got? No.
Eta is actually a naked eye star.
Is it? Okay.
And that makes it easy to, you know, put the telescope on, and then through the eyepiece, like in an 8-inch scope, you'll see it's a double where you've got this companion that's kind of reddish colored. And it's one of the brighter M-class stars in the sky.
Oh, cool. Nice. Oh, something I should mention, for those of you interested in this program, I've had a number of people ask what program it is. It's called Stellarium, like stellar, I-U-M, S-T-E-L-L-A-R-I-U-M. You can also set the date. So if Kent was going to say, hey, you remember back in 2018 on September 22nd, you can set this to any day or time that you want. And so we can go back or we can go forward in time and to find things. If I remember right, that was in September of 2018. We had a lot of planets up. Yeah, look, here we got the moon and Mars and Saturn. And we had a lot of interesting things. Oh, there's Jupiter. So, and you can also forward this to spin things around and make things slow down. I know I'm going to make you sick if we go too fast, but you can see how it's easy to see the progression of things. And of course, here's the sun. That's why the ground is lit up, because now it's daytime. So Kent, what are some of the more interesting deep sky? Hey, I've got a telescope. I kind of know my way around. What should I be looking at now? I'm going to set the date back to today while you tell me.
And okay, this time of year.
Yeah, about this time of year.
Okay, let's say you got an 8-inch scope. Real easy right off the bat. You know, we talked about the Orion Nebula.
Mm-hmm.
That's real easy to find because it's in the sword. It's visible in binoculars, and you'd see if you could pull in the trapezium on it.
Okay.
That would be a real easy kind of start type thing, and it's a beautiful object. You know, it's really neat, especially if you're in a dark area where you don't have light pollution. You get a lot of detail in the nebulosity spreading out of the trapezium.
Yeah.
So, you know, that's a really pretty object to see. Next thing is on the belt, on the eastern star in the 3, there's a flame nebula. And what it is, it's a nebula, but it's got a dark lane running through it, and it kind of looks like a flame. And it's not hard at all to see. You know, it's got an NGC number to it. I just don't remember it, but it's right off a little bit more to the east from that star, but it's really near it. In the photographs, it looks like it's touching it. So that's kind of a neat object.
There we go. NGC 2024.
Okay, there you got it.
Perfect.
And you can see how it's kind of like got a dark lane running through it.
Mm-hmm.
Yeah, they call that the Flame Nebula, and that's kind of an easy one to go for. And so, you know, for a beginner, that's pretty easy. Also, there's a really neat multiple star that's, if you take a right angle off of that eastern star in the belt, it's called Sigma Orionis. And it's a naked eye star also, but when you look at it, there's like the bright star, and then there's 2 little companions on one side and 1 little companion on the other side. So it's a multiple. It's not a double star. It's like a fourple star. I don't know if you got it. Got
Yep.
Sigma there?
I do.
Yeah, that looks really nice under low power in a 8-inch scope. So that's a nice one to go for. Another thing to go for is look at Rigel, because that's a double in the foot of Orion. And that one shows up pretty easily. So that's another nice target to go after.
Nice. Awesome. Now there was a couple of things you had listed on your list that we hadn't seen. My daughter loved it, that there's a unicorn constellation.
Oh, that's in Monoceros, I think, is how you...
Yes.
I might be butchering the pronunciation.
Nobody knows how to say it. It's fine.
Yeah.
There it is.
I was looking at the Rosetta Nebula.
Yes.
Which is, you know, that's really interesting. In small scopes, what you see is like 6 stars making up a very small cluster. And in a larger scope, there's a nebulosity around those 6 stars. In my 20-inch scope, using an O3 filter, I can actually see dark lanes bisecting that nebulosity that's around that little group of 6 stars there. And, it's just a really neat object. You can see it in an 8-inch, but you're going to have a hard time pulling in the nebulosity. An O3 filter will help in an 8-inch scope, but in a 20-inch, it really stands out.
Okay.
And so the Rosetta Nebula is just, I think what happened is those stars got born, and the radiation pressure is pushing the gas and dust away. So you get the symmetric, reef around the 6 stars there. So that's kind of an interesting one.
Awesome. And it looks like you can go, while Betelgeuse is a pointer star for us, we've got Betelgeuse and Procyon. So it's kind of more towards Orion's armpit. If you draw a line between the two, and you'll find
Oh,
it right
I'm
there.
sorry. What were you mentioning?
Oh, I was just saying how to find it between Orion and...
It's not the easiest. I usually go after the star chart.
Yeah.
And I think I use Betelgeuse and another star, and then draw a line through the two and head off into the east.
Okay.
And it gets me in the general area. But the main thing is if you pull out your binocs, look around for that little group of 6 stars.
That little group is 6 stars. Okay.
And that, they're pretty close binocular-wise, so you'll, look like maybe a chance of a cluster, but when you blow it up in a scope, you'll see the nebulosity around it. And so that's kind of a neat,
awesome.
neat one. Is the Rosetta Nebula. Another one I had listed was Hubble's Variable Nebula, and that's a lot tougher because it's small. It's a little reflection type nebula. I don't know if the nebula's moving over the star or the star's moving through the nebula, but over time they see it changes shape, and that's why actually Hubble found it on some photographs, and a series of photographs over a few decades shows a lot of variation in the shape of the nebula, and so that's kind of cool to actually see the thing change over time.
Wow.
And that's why they call it Hubble's Variable Nebula. It's an easy target in an 8-inch, but it's not easy to find. I usually start at something called the Christmas tree cluster, and that's also in the unicorn there. And the top of the Christmas tree actually has a cone nebula there, and I continue on in a straight line, and there's a little double star. And then I turn west from there, shoot straight over, and usually stumble across it. So it's kind of a weird way I find it.
Everybody has their own ways.
Yeah, I mean, it's definitely, small enough so I wouldn't suggest trying to find it with binoculars.
Right.
Unless you wanted to lay out the chart and find that roughly where it is in the sky, and then go after it at that point. But it's kind of an interesting object. I threw it in there because I think you asked me for interesting objects.
Oh, I did. I wanted to know what your take would be.
And that was Hubble's Variable Nebula is kind of cool because it changes shape over time.
It does.
And you don't see that with all the other stuff.
No.
And so that's kind of neat one. Another toughie I mentioned which is really a true toughie, is the Horsehead Nebula. And that's not far from that, the eastern star in the belt of Orion, but you have to go kind of southward out of that. And you have to have a good chart to show you where to look for the Horsehead. I've only once seen it in an 8-inch scope, and that was in Western Australia when it was almost overhead using an H-beta filter. With my 20-inch, under good conditions, you can see it naked eye not naked eye, but through the eyepiece without any filters. I usually use a 32 millimeter 2-inch eyepiece to go for the Horsehead. And it was one of those things that, in the old days they thought it was impossible to see visually because it was found on photographic surveys, I think by one of Pickering's assistants back in the old days around the turn of the century. And so, but I think everyone's seen a picture of the Horsehead Nebula. They blow it up in that area of Orion.
Nice.
It's really, they call it B33. It's actually a dark nebula.
Oh, yeah, you had that in there. Let me, is that what it's B33, right?
Yeah, it stands for Barnard.
That's it, yeah.
Barnard 30. Barnard was a crazy guy that photographed all the dark nebula along the Milky Way. And he had like a numbering system. And this one he named number 33. People put a B on there to honor Barnard for doing the work.
I see. Kent, we completely forgot to talk about Andromeda. We were just over by Cassiopeia. Here, let's give people a test. I've got a couple of constellations up. Can you tell me where the Big Dipper is? Can anybody find it? Okay, good. It's over here. Okay, I see a backwards question mark. Which one was that again? You guys tell me out loud. Come on, pretend like I can hear you. Okay, so we have Leo the lion. So if we're going to find Cassiopeia, we got to keep going. Oh, I lost my way. Wrong way. Oh, you know what? I think I have the wrong time of day. Hang on. I think...
one way of finding Cassiopeia
Yeah.
is if you know the Big Dipper, when the Big Dipper goes down, Cassiopeia rises. And so basically, in fact, one way of doing it is, you know how we were finding the North Star?
Yes.
By using the two end stars? Just continue that onward. Clean to the other side of the sky. And that's roughly where Cassiopeia stands out like a sore thumb because it looks like a big W.
It does.
It's kind of on its side when it's rising, and from here it does go below the horizon.
Right.
It comes up in the fall and, makes this big loop overhead where the Leo comes up, or not Leo, the Big Dipper, Ursa Major, comes up in the spring. So they're on opposite sides of the sky. So, if the Big Dipper is straight overhead, there's no way you're going to see Cassiopeia because it's below the horizon from here. But when Orion, when Ursa Major, the Big Dipper, is going down, then Cassiopeia will be coming up. And so it's an autumn constellation.
Perfect.
And also, we were talking about Andromeda Galaxy. That's an autumn constellation.
Yes, so we have the Andromeda. We have Cassiopeia here. I've connected the dots for you. And do you see how you can use this triangle here as a pointer to get there? You go about 2.5, almost 3 times over and drop down a little bit. And there is M31. You can. This is a naked eye object, isn't it, Kent?
It's a naked eye object. It's neat through binoculars also. You can see a lot more of it in binoculars. I usually go a different way to find. There's more than one way to skin a cat.
Oh, sure. So how do you find it?
I usually look up at the Great Square, and one side of the Great Square is the constellation of Andromeda. And, the Great Square is part of Pegasus also. But when you're looking at it as it's rising in the east, the left side of it, you've got Alpha, Beta, and Gamma Andromeda. You go to Beta, you go up 1, 2 stars, and just off the second star above Beta, there's Andromeda. I can see it in my head.
Yes. I had to get rid of the horizon to be able to see that. So here's the sun. Here's the Great Square of Pegasus that he was talking about. And here's the part that you go off of. Yeah, so the Great Square of Pegasus is not up tonight, just to kind of reiterate.
Yeah, it's a fall constellation.
Yeah.
I mean, when the Milky Way's getting overhead for the summer, it's starting to rise in the east. But, that's the way I usually go for it is, look for the Great Square and then, go left off of that. Find Alpha, Andromeda, Beta, and Gamma, and you've got it. And it is a beautiful object to look in binoculars.
Yes, yes it is.
In a bigger telescope, or even an 8-inch, you might be able to see some of there's like dark lanes going through it. You might be able to see some of the dark lanes. In my 20-inch, it really shows up well. For the dark lanes, there's also the satellite galaxies, M110 and M32. M32 is much brighter, M110 is a bit dimmer, but they're both really close to the galaxy and can be seen in an 8-inch telescope very easily.
Nice. Perfect. Let's see. You had NGC 2392. Do you want to tell us about that one?
That's a neat planetary nebula. It's kind of like in the middle of Gemini. You'd have to get the chart of Gemini there, and it's off of one hip or something like that of Gemini. It's really, the Hubble pictures have really made a lot of these planetary nebulas really memorable. And this one they call the Eskimo Nebula. And it's really neat looking in a Hubble shot. In a regular telescope, you'll get a little disc. You'll probably for sure get a good response to your O3 filter on it. But it's, basically a star has blown off its outer atmosphere over time, and you've got a white dwarf in the center.
Mm-hmm.
And so the reason they call it Eskimo is some of the early photographs of it showed like a fringe going around, kind of like a parka around the head. And that's why they called it Eskimo. It looked like an Eskimo wearing a parka. And
yeah, I've got the Hubble picture here up right now.
Oh, you got it?
I do. I took it from the astronomy picture of the day.
Isn't that weird about all the filaments and stuff in the center?
Uh-huh.
I mean, the morphologies are really difficult to try and explain how you start with a spherical star and end up with something that looks like that.
That's awesome.
And so the Eskimo is a nice, bright planetary nebula. It's probably one of the brightest ones for the winter, the great hexagon or the winter hexagon.
Mm-hmm.
There. One other object is the Taurocanus major cluster. Remember how we were talking about that one?
Yes.
That one's just, it's on the cool list of, to impress people objects. Mainly you have to go down to the lower hindquarters of Canis Major. It's kind of like a triangle down there. And the western two stars that make up the western part of the triangle, you draw a line extending it out, and you'll come across a pair of stars. And one star is, they're actually vertical. One star is this Taurocanus Major cluster. The other one is just a regular star in the constellation.
Mm-hmm.
But the cool thing about the Taurocanus Major cluster is you have a bright star, and then when you look at a telescope, there's all these other little stars around it. It's a nice, tight, open cluster with a very bright star in the center. They're not quite sure if that very bright star is actually a member. If it is, it's a super bright star.
Mm-hmm. Oh, we have a question here, speaking of stars. They're asking, what are double stars? Do they actually rotate around each other, or are they just optically next to each other?
Actually, both. You have to look at it a long time. If it starts changing angle with respect to the brighter one, you know it's a gravitationally what they call binary double star. And if the thing just keeps on going, or you can also look at the radial velocities of the thing. If they've got a wide disparity in radial velocity, they're probably just line of sight binaries, or not binaries, but double stars. So, in fact, William Herschel is the first person to discover the motion of, true binary motion, and that proved that Newton's gravitation worked out in the heavens. So it was a big deal. He kept looking at measuring the position angle of these variable stars, and after a couple of decades, he started seeing the position angle was changing. So one was orbiting the other, and that was a big deal back, I think it was probably at the end of the 1700s.
Now, speaking of double stars, I know this one isn't up tonight, but it's my personal favorite. And Dave Majors, if you're out there, it's your fault, because when you showed me this star, I was like, oh, that's easily my favorite double star. Let's play a game. You guess it, Kent. There's an orange one and a green one, and they're real close together.
And orange one and a green one, okay.
Or a green. There are no green stars. Did I seriously say that?
Yeah, I said an orange one and a green one. You'll
never guess it. There are no green stars. How about an orange one and a blue one?
Probably the most popular, colorful double star is Albarial.
Yes, you got it. You got it here.
A blue and a yellow. But also, remember how we're talking about that Taurocanus Major cluster? Just north of it is what they call the winter alberyle, and that's a really colorful little double. I forget what the colors are, but they definitely have a contrast. And once you find that Taurocanus major cluster, all you have to do in your eyepiece is look above it, and there'll be like a star, little ways above it. Center it on that, and you've got a nice, colorful winter double. But alberyal's like the number one, I think, popular one. For most people see gold and blue on alberyal.
Yes, except for me. Apparently now I'm seeing green stars. So wow, that was pretty impressive.
Well, a lot of planetary nebula are green.
They do. And why do they look green? You want to talk about that?
But that's mainly due to the nebula, not the star itself. In fact, a lot of them you can't see the star because it's giving off too much ultraviolet, and our eyes don't see ultraviolet, even though it makes the whole nebula for us. Like, for a real example, or good example, is the Cat's Eye Nebula in Draco the Dragon. I've shown that to folks at the Star Party for quite a few years. And when you get it in the 20-inch and you get it nicely focused, you'll see the nebula around there, and some people see it as green, some people see it as blue, some people see it as turquoise, but then there's a little yellow star in the center when the scene's really good. And that little yellow star is making the whole nebulosity glow. And if that yellow star was shifted fully to visible light instead of ultraviolet, it would be a naked eye star. You would be able to look up in Draco and see a bright star up there where there's nothing right now. I mean, you can't even see the nebula. I mean, it's really faint. But to me, that's truly amazing how much energy the thing's putting out, and we can't see it at all.
Yeah, that's amazing. All right, let's see. I think people are just saying, thank you so much. This is amazing. I can't wait for the next one. So let me see if there's any other questions. Let's pause for a minute here. Can you share more information about your website? The Central Coast Astronomical Society is ccastronomy, or centralcoastastronomy.org. So you can find all kinds of information on there, including our next star parties and so forth. As long as we are still kind of in this health concern time, we plan on doing this if this is a good format that works for everyone. So what I need you to do right now is, everyone, take out your typing fingers, even if you haven't typed anything yet. Go ahead and tell us how this experience is for you. I'm actually going to download these questions and comments and send them to Kent. So if you want to give him any kudos, any questions, or any comments, please do that right now. And that way we'll know how this format is working for you. And if you like it and you want more, what could we improve? What could be even better? Go ahead and type right now. Kent, I've got a couple of questions that you can answer for people while they're doing that. Question is, how about this is from Tom, Tom Fry. How about the double cluster below Cass and Mizar and Alcor in the Dipper? So let me show you that. You want to talk about the double cluster in the Dipper? Let's see.
There's a double nebula, which is actually M51.
Okay.
But I'm not aware of any open clusters in the Big Dipper.
I think he said a double cluster.
Yeah, there's no. I mean, the double cluster is actually below Cassiopeia. We never got around to that. Remember, we were talking about how the double cluster is a naked eye object. It's fuzzy, but you can pull it out, especially if you use averted vision when you're looking up the sky.
Yeah. Why don't you talk about averted vision here? Go ahead. I'll bring Cassiopeia up.
Oh, you want me to talk about averted vision?
Yeah. What is that for people that have no idea?
Okay, your eye's got two sections. When you stare at something, you're actually using your colored vision. It's right around your focus, and that's what they call the cones. Those actually are your color vision, and around that there's a big area on the edge. You're actually not on the edge, but beyond the cones, which are the rods, and those are black and white, and they're more sensitive to small changes in brightness. Essentially, it's the closest thing you've got to night vision is the actual rods versus the cones. So when you're looking through a telescope and you're looking at something faint, if you look off center a little bit, sometimes the thing will pop up out of the corner of your eye, and that's what's called averted vision. When you move your eye a little bit and stare right at it, it disappears. And then you look off the side and it pops in again. And it's something that as you practice it, it gets better and better, and after a while you use it without thinking about it. But it's, in the beginning you have to physically think about using averted vision. And when you look up at stuff in the sky, like we were talking about the double cluster, you don't stare right at it. You kind of look off center from it, and you'll see this fuzzy, actually two little fuzzy blobs up there. And if you turn around and stare at it, it goes away. So that's what they call averted vision. It's using kind of like out of the corner of your eye vision.
Perfect.
Does that make sense?
Yeah. Well, I'm the only one who really can talk to you, so yes. But I got a bunch of thumbs up from everybody. People would like to hear more. They would like you to go even deeper into some of your favorite observations and definitely include your stories.
Oh, okay.
So I don't know how you want to take that, but I got that from a number of people saying, please keep talking, don't stop.
We'll have to do that as an object at a time.
I know. Why don't you just pick maybe your single favorite or your maybe two top favorites?
My specialty is planetary nebula. Mm-hmm. So, I've gone nuts on planetary nebula. I took 4 trips down to Western Australia to see the other side of the sky. And
we can do the other side. Just tell me what you want to see. No problem. I can get rid of the horizon. I can get rid of the atmosphere. We can go anywhere you want.
There's some amazing things to see down in the southern hemisphere.
Okay.
There's actually a great big emissions nebula called the Eta Carinae Nebula, which is naked eye. You look up there and it's monstrous. And it puts the Orion Nebula to shame. And you can actually see kind of a V shape, and in binoculars it's really cool. And that's where the Eta Carinae star is, and that's the one with the 2 lobes that blew out, I think around 1840. It actually went through an eruption and blew out lobes in opposite directions. But you can actually see details in the lobes, especially with a 20-inch scope. But that's unique to the sky. The other thing are the Magellanic Clouds, mm-hmm. which are the Milky Way's kind of little galaxies that orbit. They're not quite sure if they're in orbit around the Milky Way or just passing by. But those are amazing. They're both naked eye objects. You can actually see a great big emissions nebula called the Tarantula Nebula in the Large Magellanic Cloud. And I was curious about whether I could see any planetary nebulas in the Magellanic Clouds, because I think the large cloud is about 160,000 light years away, and the small cloud's about 190,000 light years away. So they're way out there. But I was able to see about 70 planetary nebula using an O3 filter in the large cloud and about 20 planetary nebula in the small cloud. But the thing about the Magellanic Clouds is you can't star hop through them. It's so loaded with clusters and nebulas and supernova remnants and things like that. You just kind of hop from nebula to cluster to nebula cluster. You need a good chart to really nail down positions in there. And so they're fantastic objects. And probably the neatest thing is right next to the small Magellanic Cloud is what looks like a star. It's called 47 Tucana. And what it is, it's what I consider the best globular cluster in the sky. In my 20-inch, it fills the 32-millimeter eyepiece, and you see color in the center. The stars are yellow. And I sent a postcard to my old buddy Larry, and I go, Larry, this is really close to a religious experience, seeing 47 Tucana in a 20-inch scope. I mean, it's also condensed in the center and then spreads out. Unlike Omega Centauri is probably the biggest globular cluster, it's kind of even all the way through. It isn't concentrated, where this has a concentrated center very symmetrical and then spreads out. But seeing color in the stars in the center of it just blew me away. And so that's a good story, I guess, about the 47 Tucana.
Perfect. I've got that one on the screen as well.
Yeah, it's also called NGC 104, if I remember the number correctly.
Let me see. Yes. Oh my gosh, you're amazing. Yes, it is NGC 104.
Yeah, it's a fantastic object, but it's so far south that you have to go to either South Africa or South America or Australia.
Mm-hmm. Now, you brought your obsession to Australia, didn't you?
Pardon?
You brought your telescope to Australia, didn't you?
Yeah, the first trip, I wanted to see if I could break 400 planetaries.
And?
I'd seen like 303 planetaries with my old 8-inch. And so I actually hauled it on as luggage. I bought a special case to put the optical section in and got a big duffel bag for the tripod and got a collapsing tripod. And it weighed I think I was lugging like 132 pounds through the airport. This was in 1999 when you could get away with that sort.
Good luck today.
Yeah. I mean, I was able to, haul it on as luggage, and ended up on New Year's Day, or actually, New Year's Eve of 1998. That was it. New Year's Eve in Perth, Australia, with this big load of stuff. And I spent like a week in Perth just getting used to driving on the wrong side of the road and playing. It was during full moon, so I played tourist for a while. And then I rented a car, and I had a friend over there that I followed him all the way out to the boonies, Wongan Hills area, which is way north of Perth, to get out of the light pollution. And it was good I followed him because I got used to driving on the wrong side of the road and using, roundabouts. They've got roundabouts all over the place there. And, I could drive an Australian roundabout, but I'm not sure I could drive one here in the U.S. because it goes the wrong way. But the good thing is the steering wheels are on the other side. So as long as you keep your steering wheel next to the line in the middle of the road, you're okay.
Yes.
And he got me access to Mr. Fuji, who's a famous Japanese astrophotographer. He has an observatory in a place called Yurcoin in the wheat belt. And that was some of my first observing, was at Mr. Fuji's observatory. And so that was a lot of fun, because basically getting used to I studied for like a year, trying to, understand the sky down there and all of that. Actually I didn't have any problem with the southern sky. The thing that bothered me was watching Leo come up, because Leo came up upside down. I was going to Morris. I was going, Morris, what is that? And he starts laughing, and he goes, you've never seen Leo rise upside down, have you? And I go, no, that's what it is. It threw me off. The northern stuff was all upside down. Orion is upside down when you're down there. And so Betelgeuse is down and Rigel is up. And so it kind of does throw a curveball to you for the stuff that you're used to. Also, they call Orion the shopping cart.
The shopping cart?
The shopping cart, yeah, that's a nickname for Orion, is the shopping cart. And so, I studied a lot of the magazines and books, whatever I could get my hands on for astronomy, in the southern sky. And it well paid off because, I wasn't lost trying to hunt down stuff. And I had some good charts I brought along with me. I brought a Uranometria 2000 for the southern sky. Hauled that along with all the other junk I hauled down there. But it was really useful having a guide there, and that was Morris Clark. He was a student and working on his PhD at Murdoch. There's a Murdoch University in Perth, and the same Murdoch that I think owns Fox and all of that. And he was working on his doctorate in the physics there. But yeah, I had a lot of fun. I spent like 3 months on my first trip in Western Australia with the 8-inch. And that was, right at the beginning of 1999 when I got there. And, January. The thing is, the seasons are reversed.
Right.
So basically I missed out on winter and, had like 2 summers that year.
Right.
And so that was nice. And also the weather, I looked at the weather patterns. And, basically what was up at that time of the year in Western Australia was, that was the place to go and look at stuff for continuing my survey of planetary nebula. And actually I went from 303 to like 418 on that trip. So I broke 400 with the 8-inch, with the use of the filters and that sort of thing. So that was something I've been meaning to do for a long time.
Oh my goodness. Okay,
And
so what I've done right now while you've been talking is I changed our location. We're in Australia, and we are seeing Leo come up upside down.
Yeah,
So,
I remember something,
yeah.
Aurora. In the old, our club had an old setup for, how the web page was presented. And in there, I actually had my Australian adventures. I don't know if you saved
I have
it.
those actually.
That is a whole thing about my trip.
Yes.
And Walt put links into it so that if you looked at Wave Rock, it linked you into Wave Rock, which is a really neat formation in Western Australia. But it's really the tourist side, not really the observing side that much, but the tourist side of what I did when I was in Western Australia.
Okay. Let me look and see if I can find them in the archives, and I'll...
Yeah, it's definitely be in the archives because I tried to find it on the website before, and I could find the Navajo Flat pictures.
Yes.
But I could not find the old Australian adventures.
Okay.
And
well,
so
let me see what I can do to find those so folks can definitely... Oh, there's Orion, and he's upside down. We're just ignoring the sun right now.
Upside down stuff. The other thing you had to watch out for is kangaroos.
Are they friendly or no?
They're like deer here. They'll go through your windshield.
Ooh.
The only problem is they're bottom heavy, so they'll kill you if they go through your windshield. No. They'll squish you.
That's
the people
not
in
good.
Western Australia have roo bars on the front of their cars. They're big metal, pieces that go up, and essentially it'll push the roo out of the way so it doesn't go through your windshield. And everyone seemed to, the natives, they had, because it's just like deer, they get out on the road at night, and they can jump a lot higher than a deer. Well, a deer can jump really good also.
That's amazing.
But I remember one time I was coming back late at night, and I come around the corner, and I'm not going fast because it's like 3 o'clock in the morning, and here's this big male roo, kangaroo, right in the middle of the lane looking at me. It's like, how dare you drive? So I stopped, and he gave me the dirtiest look, like, how dare you be out driving around at night? And then he hopped into the other lane and again gave me another dirty look.
Oh, no.
And then finally hopped into the distance. But, that was my, my big encounter with an angry roo.
Yay.
I'll tell you, it was a lot of fun doing that.
I bet.
I was that was for my 50th birthday, time frame.
Yeah.
And so there was that trip, and I took 3 more trips after that one, but I air freighted the 20-inch to Australia, and that's when I went after the planetary nebula and the large and small Magellanic Clouds, and also a lot of other faint stuff.
Yeah, awesome. We have a number of people asking about what kind of telescope you'd recommend if they're moving beyond binoculars. So is there a certain brand? Go ahead.
Actually, the easiest to use telescope is one of the old Celestron, what they called the C8, Celestron 8-inch Schmidt-Cassegrain.
Oh, I actually have a Meade LX200 behind me. Is it similar?
It's similar, yeah. Meade and Celestron are competitors.
Right.
And the Celestron came about first, but it was the most popular telescope, the old orange tube ones.
I have a picture of you with yours. Is that one?
Yeah, that's the old style. The tripod was double bars for each leg.
Mm-hmm.
Very stable type of telescope. Very easy to use. I mean, the controls for moving it, right ascension, declination, you could look through your eyepiece, reach out, and move the controls. Very, very easy to use.
Mm-hmm.
And there's used ones out there. I've seen them as cheap as like $400, which is dirt cheap. I think there was a pawn store. Yeah, the pawn shop here in Tascadero was selling one for $400. I mean, I actually paid $800 for mine a long time ago. And it was used. I got it from a Cal Poly student. But it has really good optics.
Good.
It's really easy to use. You can convert it to alt-azimuth, so you don't necessarily have to track, although it has tracking motors in the base of it. So, basically, that's the one I first got was for a big telescope. Before then, I had a 4.5-inch reflector that had a German equatorial mount that was horrible for trying to point at anything. I really don't like German equatorial mounts because it gets you into an angle where you can't get to where you want to go. And so, for photography, they're perfect. But for visual observing, I don't like German equatorial mounts. Mm-hmm. And then I used to have, as a teenager, was a Sears, I think it was Sears brand, or was it J.C. Penney's, little alt-azimuth 60-millimeter refractor. And I used that for a lot of double star work, but it was just too small to go, really after deep sky objects very well.
Yeah.
But the Schmidt-Cassegrain, just a really nice scope, real easy. It went into the optical tube goes into a foot locker, and the tripod can fold up if you want. Mm-hmm. I just would throw it in the back of my old pickup, and so very easy to set it up quick. And they had a lot of accessories because it was like the most popular telescope at the time of about Halley's Comet, and so they actually came up with vibration suppression pads. You get 3 of them. They look like hockey pucks. You put them under the legs of your tripod. Mm-hmm. Excellent for reducing vibration. So when you're like turning the focus knob to get Saturn's rings nice and sharp, mm-hmm. I used to have to kind of let go and let the vibration damp out and then see whether it was good or not. With these, you could just focus right in, no problem. It just absorbed all the vibration. Oh. And so very, very useful. And there were tons of vibration suppression devices they sold for years before that. None of them worked they worked very poorly. These worked excellently.
Okay, good. I got a couple other questions here. Let me answer this one. There's people want to know what is good for families. So having a telescope like this is big and heavy. The Schmidt-Cassegrain, this LX200. They're heavy. I remember when I first got it, I'm like, oh, it's short, it's compact. I'm going to throw it in a backpack and go hiking. I can't lift this thing.
No, they do have enough weight. Some are heavier. It depends on the size also.
I know. So this is an 8-inch one. So the whole thing weighs like 80 pounds. There's no way it's going to fit. So Orion at that point had sold a backpack that would fit. They claimed it fit an 8-inch with the tripod. I've never gotten it to fit, and it's too heavy, and also it's way up high. So for kids, a lot of people want to buy a telescope that, it's on rickety tripod legs and it looks like a telescope, but those are really hard for families. So instead, what I recommend is a Dobsonian, which looks like this.
Oh, Dob?
A Dobsonian is great for kids to start with because they can just
Oh,
grab
yeah.
it, muscle it around. It doesn't tip over easy. It's
They've got low center of gravity.
low center of gravity, exactly. And
Actually,
they're not
for
that
kids,
expensive.
well, for kids, start off with binoculars.
Yes. So, well, yeah. Okay. So
That's
we're talking
number one.
binoculars
Start
for
with binoculars,
kids.
and then those, 8-inch Dob is really nice. As long as you don't knock it out of calibration or collimation. That's it.
Yes. Then they'll get good at collimating it. But yes. So binoculars first. Once you guys know where to, because telescopes are pretty useless if you don't know where to point them. So once you figure that out, then you can graduate to a Dobsonian. And then from there, it depends on what kind of observing you want to do.
My advice was more for an adult.
Yes, so for adults, it's the one you have.
Smith-Cassegrain is really nice for an adult.
Yes, it is.
For kids, yeah, you start with binoculars, and then a Dob is really nice. The nice thing about the Dobs, even a 6-inch Dob, is that they have solid tubes.
Yes.
So you're not likely. You got to really beat it up to knock it out of collimation. With my 20-inch, I got to collimate it every time because I take it apart and put it together each time.
Yes. Oh wait, let me show people your. Oh, I showed people that one. Let me show the. Tom Fry also has an obsession. You have a star. What is it?
Oh, sorry.
What's the name of your 20-inch?
Oh, it's a star splitter.
Star splitter. That's right.
It's like a cheap duplicate of an obsession. Except the guys made them in California, so I could just drive down to L.A. and pick it up.
Mm-hmm.
And so it's actually, the mirror in it is an excellent mirror. It was made by the Galaxy company, and the mirror is actually signed by the optician that did the work.
Oh wow.
And dated. So it's an excellent product. The mirror is worth more than all the other stuff that goes around it. I mean, it's an excellent mirror. I got 96% reflective coatings on it. So, it's really got a good figure to it. Mm-hmm. And, if I've got it collimated properly, it gives, you've seen the images in it under good conditions. It gives really nice images. Mm-hmm. But the problem is the lower section weighs 150 pounds.
Yes.
And so I got to wheel it in. You got to put it together. You really have to start looking. If you're older, look at where you're going to throw your back out or damage your back. You want to. I could have got a 25 or a 22, but I felt a 20. I'd actually seen and used a few 20s up at Mount Pinos. Mm-hmm. The Jim Brunkel is the guy that built the star splitter telescopes, and he brought several of them up there, and I was really impressed on the movement of the thing, and also how easy it was to use. So, I decided I had to do some measurements, like the pipe fence out at Navajo Flats. I had to make sure I could fit it under the pipe fence to roll it out in the field.
Right.
And so there was all sorts of stuff that I had questions about, and then I had to be able to fit everything in the back of my Toyota pickup with the camper shell. And you've seen how I fit everything in there. It's like putting clowns into a little Volkswagen. All
right, Kent. Well, I think thank you so much. We've been at this for about an hour and a half now.
Yeah, I see it's like 8:38 on my
I know. People are
here.
Still piling in questions, but I'm going to actually wrap this up for now. I want to say thank you so much for taking the time to do this. Almost everyone has asked, please do this again next month. So we'll see how you feel about that.
This was a lot of fun.
Oh, good.
Thanks for asking me.
Oh, absolutely. And if you have individual questions for Kent, you can just send me an email. I'll compile it and send it to him. But I just wanted to say thank you, Kent. So I know everybody's yelling thank you right now. So thank you and enjoy your night. I hope you've learned something. Next week, we are going to have Dr. Bob Field from the physics department at Cal Poly presenting the same format we're doing now, only you'll actually get to see him. He's going to be presenting his slides, so you can participate in our astronomy meeting right from home, just like this. So I look forward to seeing you then. I will send you an email with that reminder. And if you'd like to give Kent kudos, and I will see you guys next time. So thank you so much, Kent.
Oh, you're welcome, Aurora. You take care now.
You too. Bye-bye.
Okay. Bye-bye.